So in this tutorial we'll try to model this is for one of my client. So let us try to model it. The total length is 10, 20, 30, 20, 20, 15. So the total length would be, let's check how much is the total length. So total length is 10 plus 20 plus 20 plus 20 plus 15, 85 centimeter. Okay, so the tank total length is 85 centimeter. In meter it will be 0.85. So for that, what I'll do, I'll model the tank using rigid, because I don't need the deformation of the tank. So what I'll do, I'll rigid and I'll use shell. I'll use extrusion. So for this, what I'll do, okay, let us first make a planar shell. So the tank diameter we need now. Let us check the tank diameter. So these are the details. So barrel diameter is 0.3 meter. Okay, so for 0.3, diameter is 0.3 means radius will be 0.15. Yeah, 0.15 radius. So it is very tiny because I have kept the grid spacing like that, no issue. So you have the base. Now we need to extrude it. We need to extrude the shell. Now for extrusion of the shell, I'll use the same diameter. Now in which direction I want to extrude? I want to extrude in this direction, and the height will be 0.85. So we have our tank now. Okay, I made a mistake. This should not be solid. I'll have to find out the shell. So for getting this shell, okay, so this is the shell extruder. I should have selected this one. So now I'll make it of the same shape. It will be 0.85. Done. So we have our tank now, and as I have mentioned, I have made it discrete rigid. So I'll have to assign a reference point. I'll assign the reference point at the bottom. Why I have created it as a discrete rigid? Because I am not interested in the deformation of it. I am only interested in the deformation of my soil model. Now I need to create the soil model. For that, my soil model will be of same size and thickness. So I'll create the soil. I'll use solid extrusion. It will be diameter will be of 0.15 and I'll extrude it up to 0.85. So this is my soil. Now I'll take both my soil. Okay, hold on, there might be a mistake. I need to check it once more. Okay, so full soil, that's correct. I'll take both of this. Okay, so there is an issue. A solid cannot be installed in assembly, it can be converted to shell by using. Okay, there is some issue, so instead of making it here rigid, what I'll do, I'll make the tank now. For the time being, I'll make it deformable and later I'll make it rigid. Using the interaction properties, I'll make it rigid because Abaqus has some issue with it. Okay, sorry, I made a mistake. I made a big mistake. Actually, I didn't notice that. So my tank will be discrete rigid only and my soil will not be discrete rigid because I need that deformation of it. This is the mistake I made. So these are my, now I have my tank and the soil. So you can see this is my soil and this is my tank. So what I'll do now is I'll rotate both of this and I'll make it vertical. I can keep it like this, but still I just want to make it vertical. I'll rotate about x-axis. I think it should have been minus 90. Yeah, now that's fine. Now if I keep it like this, if I just hide the tank, we have the side. I have hidden the soil, so we have the tank now. So both are okay now. Now here I need the pile diameter and pile height. So pile diameter and pile height. Let us make the pile first. Pile. So the diameter of the pile is 0.025 meter. That means the 0.025 into 0.5. 0.125 is my radius. 0.125. So that's my radius. If I just click this, I'll get over here. This is because I have kept this grid spacing very high, which is why I'm getting it. You can, if you reduce it, you can visualize it properly. Pile height is 1.38 meter. 1.38 meter. So this is my pile height. I will go to assembly. I will take the pile also here. Again I made a mistake. I didn't notice it. My pile will be deformable instead of discrete rigid. This is my pile. I'll rotate my pile about x-axis. done. 90°. Let this be -90. Okay, now I'll have to position it properly. For that, what I'll do is during the bottom of barrel is full of soil and the pile is placed on top of that layer. So pile is placed top layer at 15 centimeter from the bottom. So I'll have to create a point from here, or I would say from bottom. So from bottom I have to select this point. This is my bottommost point and 15 centimeter, that means 0.15 meter. So x will be 0, y will be 0.15 and z will be 0. So at this point I must place my pile. So I'll place my pile over here. So from this point to this point, my pile is placed over there correctly. Now to visualize it, I'll use this view. Now see, my pile have been placed properly at 15 centimeter above. Okay, now what I'll do, I'll create a groove and so I'll create a groove in the soil. So for that, what I'll do is I want to cut. So for cutting, I'll have to use this, select a plane. This is the plane. I'll place it on the right side, and this will be the radius of pile 0.0125, and this cut will be made up to it will be of minus 0.85 minus 0.15, 0.7. This much groove is there. Now if I take it to assembly, just want to check it. I'll use this. And if I just make this, you see my pile have been placed properly. I'll apply it. Okay, I've hidden the pile. You can see the groove is created properly. Now I'll create a partition for it so that I can mesh it properly. For that, what I will do is I'll use this. I'll extend this edge in a direction. Okay, I'm not getting any straight edge or a data axis. So it is asking me to select a data axis. I'll select Z. Okay, I need to create a data axis here. Create a data axis, principal axis. I need Z axis. So I'll select the data axis, this, click OK, create partition. So we have got partition here. Then I'll create the partition using the face. Okay, so we have created the partition for easy meshing. So our modeling is nearly completed. Now just need to assign the boundary condition, the friction and all, and this step. So we'll be using, let us check what model can be used. Material steel for pile, density will be 7850 kg per meter cube, elasticity will be 2.1:5, Poisson's ratio 0.3, and I'll use one plastic value for 10 MPa and 0. So this will be steel, and then I have the soil. For soil, my client have given me the data. So for that we have density 78, word ratio, elastic property. Okay, so they have given me the elastic property 114, density I'll use, here they have given relative density. For that what I'll do is, he has given me some density also. Density is 1900 kg per meter cube, so I'll use the same density. (1900), then mechanical elasticity 114. That's what it has written, Newton mm. So e raised to the power, because if you check it, it is MPa, which is Newton per mm square. So mm square will be 10 to the power minus 6, 10 to the power 6. Okay, we are using in meter, right? Okay, and Poisson's ratio will be 0.15. So I need to change it for the steel also, and the material they have used is Dakar pressure. So let's check what are the material. If I use Dakar pressure, dilation angle of friction, angle of friction is my (50.2), flow stress 0.778, and dilation angle is 20. Pressure hardening 0.130, 0, 0.2, 0.207, 0.164 into 3. Here the strain will be 0.01, 0.032, 0.032, 0.098, 0.258. So we have used the hardening behavior type. So the material have been created. Let us assign the material. This is my soil. I'll assign the material for soil. Use homogeneous soil. Done. Then pile is made up of steel. Assign the pile. For pile, I'll create pile homogeneous. I'll make steel. I'll select the pile. Done. Now I forgot to modify one thing, that steel I have given this is in mm square, so it will be e raised to the 6, and this will be also e raised to the 6. So all are in meter. Now one more thing, this value is in MPa, right? So I'll have to convert it to meter. So I made another mistake. So these are silly mistakes, you must have to take care of it. If you do not, then your model will give you incorrect results. So I'll have to add e raised to 6 everywhere, because all these are in meter square, not in square. So from meter square to square, you'll have to these are stress values, so Newton per meter square. So square it will multiply with e raised to 6. Now everything is correct. Material assignment have been completed. Now I need to add few more things. These are my user. Now I need to add few more things like this, conductivity and all. So edit, mechanical, go to thermal conductivity. The conductivity is, soil conductivity is 3 Wmk. 3, specific it 800, density I have used. Then for steel also, conductivity 64. Let's check the unit once, and it is 466, specific it 466. So what I will do, I'll check the unit once. So my units are correct. Next we'll try about the heat transfer. So for heat transfer model, I'll show you now. For heat transfer model, you don't have to do anything else. To follow the same procedure the way you have model. I'll show you up to what you'll have to keep everything same. I'm deleting all this because I have created it previously. So to step by step here, basically my aim is to check how the heat is getting transferred from the pile to the soil. Okay, so follow everything same as that of model 1 up to this assembly and property assignment. So follow everything as that of model 1. In model 1, first I have created all the steps. First I have created all the part, then I have taken it to assembly. I have arranged it in a suitable pattern or suitable configuration as per the requirement. Then I have assigned the properties. Okay, so up to property you follow everything same. Once it is completed, then go to simplest step, and here in the step you will have to create a different step for the heat transfer. So for the heat transfer, for the normal model we have created dynamic explicit. For the heat transfer we'll have to create the heat transfer transient analysis. Let us create a heat transfer. I'll name it HT. You'll get the option here, heat transfer, and you'll go for a transient analysis and time period, for how many seconds you want to simulate. So for example, let's say I want to simulate for 10 days. So 10 days will be 3600 36,000 seconds. Incrementation, what are the maximum allowable temperature per increment? I'll keep 1 degree temperature maximum allowable. And initial size, I'll simply, you can keep any value. This one you increase maximum number of increments to a higher value like 1 million for the safety. And minimum, let this be 0.36. Initial, I would say initial I would give 0.1 for the increment, and maximum you can give many more, but this will take care of this maximum allowable temperature. Let's say I'll give maximum as 100. So don't worry, don't bother about this very much. This software will automatically take care of it. This just software is taking some data from you. It does not really matter. Software has capacity to handle it. Maximum must be less than or equal to initial. Okay. So the maximum, it is minimum increment equal to or must be less than. So minimum increment will be equal to or minimum less than 0.1. So now my heat transfer step has been created. Now once it is created, go to here. Now in thermal, select nodal temperature, heat flux, and this reaction flux. Okay. Now once it is completed, go to interactions. Now you'll have to create an interaction property which will be used by the pile and the soil to transfer the heat. For that I have created previously, I'll create now also. Let me show you first. Thermal conductance will be using at 0 clearance, conductance will be 1.2, and at higher clearance it will be at 5, after 5 meter there will be 0 conductance. So I'll delete it and I'll create now again just to show you. So thermal conductance, thermal conductor. So I'll use some higher value, like for 500 conductance. Say conductance is very high at 0 meter, means if there is a connection between pile and soil, because on the connection, the spacing between the pile and soil is 0 meter. At 0 conduction of 500, and at conduction of 500 at 5 meter, just for the and this is the radial displacement, let's say for 50 meter. So it will interpolate it in between the length. So now the interaction property have been created. We need to create an interaction. This I have created previously. I'll delete now. I'll go and I'll use surface contact. I'll make it initial. Instead of surface, I would go for general contact standard. Yeah, let's go for general contact. So if there is an interaction between the two instances, it will use the general contact. So there is an issue, general contact is not available. It says it is not available. Then let's create surface contact. As you can see, general contact is not available, so we cannot use general contact here in the heat transfer. So we'll use surface to surface contact initially, surface to surface, surface to surface, then the master surface. Master surface will be my pile surface. So I'll set everything off. I'll simply switch on the pile. I want to select the master surface as the pile surface, and the slab surface will be the soil surface. And that's all. The soil surface, I would say I would select everything. I would select everything in the soil surface. So that is the interaction that will be used while analysis for heat transfer. So in heat transfer, this is what will be used. Next is my okay, heat transfer interaction have been completed. Now one thing I would like to mention, as the tank, see, I have here suppressed the tank. You can resume the tank, because when you'll be modeling, you can see the tank and everything will be there, pile. But in heat transfer, I'll simply suppress the tank, because I don't need the tank. Yes, you can keep it, but unnecessarily it will increase the element size, because my basic aim is to check the temperature distribution, or how the pile is transferring the temperature to the soil. Okay, the what I would say, the tank is there just to keep the soil in its place. So what I'll do, I'll not use the tank here for the heat transfer. I'll just simply suppress, or you can delete the tank. I don't need the tank here. I'll just simply keep the pile and the soil to check the heat transfer, because even if I keep the tank, it will not make any difference in the heat transfer. But be careful, you'll have to keep it for model 1 and model 2, model 1 for normal and model 2 for freezing. But for heat transfer, we don't have to use the tank and all, so I'm not using the tank here. Now let's go to boundary condition. In boundary condition, I'll be using temperature for the pile, because pile temperature will remain same. It will be, though it was 0, now here I'll modify the pile temperature as, in heat transfer step, it will be -24. Next, I have to assign some temperature to the soil. So my soil temperature would be my soil temperature would be +1. Soil temperature would be 1 degree Celsius. So soil is of 1 degree Celsius temperature. And why I have used the predefined field, because here over here, as you can see, it can be computed, it can be changed, the temperature will change for the soil. But if you assign temperature from here, it will not change. The temperature of the pile will remain same, -24 degree, throughout the analysis. So our modeling is completed now. Again, I am saying you don't need the tank, because we are not simulating the temperature in the tank. Even if you keep the tank, it does not make any difference. For the safety and for time saving purpose, I have not used. And next I'll go to mesh. Similarly, as I've shown previously, you can assign any seed, and you can simply mesh it. Now once it is completed, you can run the analysis. So same, create a job and submit the analysis. That's all. And you can visualize the results. Once it is completed, I will show you how to visualize the results.